Good morning, students. We had discussed about work, definition of work. We had also discussed about the two special cases. The first one when theta is equal to 0 and the second one when theta equal to 90. So when theta equal to 90, the work done is 0. So it gives you two conditions when work can be 0. The conditions are work can be 0 if theta equal to 90. Second condition, when displacement equal to 0. When displacement is equal to 0, then also the work done will be equal to 0. If you keep on pushing an object, it doesn't move, the displacement is 0. Or a particle that moves and make a complete circle, it comes back to the original position, then work done is 0. Like a person who is running on a circular track and he starts and come back to the final initial position, then work done by him is 0. Okay? So, because the displacement is 0. Then the third condition, third case, case 3, when theta equal to 180 degree. Now, cos 180 is equal to minus 1. What is this case? Now, we come back to the second case. We had a coolie with load over his head walking on the platform. According to physics, he is doing no work against the gravity. Work done against the gravity is 0 because cos 90. Then why are we paying him? Why does he demand money? If he is not doing any amount of work. He is not doing any work against the gravity, but there is another force that is acting on him against which he is doing work. So you know that when any object moves, there is always a frictional force acting. So, when you displace an object in this direction by a certain distance s, then you are doing work against the frictional force. This angle is 180 degree. Is it clear? Whenever we walk, we are doing work against the frictional force. That is why we are getting tired. Okay? आपने देखा होगा चलते चलते चप्पलें घिस जाती हैं. चप्पलें क्यों घिस जाती हैं? क्योंकि हम फ्रिक्शन के अगेंस्ट काम करते हैं. सड़क पर हम चलते हैं तो टायर के थ्रेडिंग्स घिस जाते हैं, टायर घिस जाते हैं क्योंकि वो काम कर रहे हैं अगेंस्ट द फ्रिक्शनल फोर्स. सो वर्क डन इज इक्वल टू माइनस एफएस. ओके, minus means negative work. Work has to be done. You have to do some amount of energy has to be spent. It means negative work done. Another case, you throw a ball in the upward direction. Okay, the displacement is in this direction, s is in this direction, and the weight is acting in the downward direction. Weight is acting downward. The angle is 180. Work done is negative. When we throw any object in the upward direction, work is done against the gravity. The angle between the displacement and the gravity is 180. So work done is negative. Here in all these cases, there is one important point that is to be kept in mind. Work done, in the case of work done, F is always constant. Okay, constant, we say 10 Newton force is being acting on an object, 20 Newton, 100 Newton. The value of force does not change. Is it clear? Okay. If the force is variable and the displacement is continuously changing. Now here in this case, both force and displacement are varying. So we will calculate out the work done by graphical method. We plot force and displacement on the x-axis and the y-axis. Okay. Now here, look here. The force is continuously increasing. Force is continuously increasing, and the displacement is also increasing from 0 to s here. Okay. Now work done. Work done will be given by the formula F work done. The area under the graph will give you the work done. So area under the graph will be given by work done. So work done area will be half. This is F of F into S. This is the formula for variable work done. Clear? When the force is variable, force earlier was 0. It kept on increasing as the displacement increasing. Then in that case, work done is given by the area under the graph W equal to 1 by 2 Fs, because it's a triangle, so half base into height. Then second case, if force is constant, then also we can calculate the work done by graph. Here you can see the line is parallel to the x-axis. The line is parallel to the x-axis. It means that force is constant. Then the area under the graph will be the area of the rectangle. So that is work done equal to F into S. Okay. So graphically also we can calculate out the work done. But here you should remember that in the case of a constant force, work done is equal to Fs. In the case of a variable force, work done is equal to 1 by 2 Fs. Okay. Next we have work done by the force of gravity. So we have got an object wall, a ball. It is falling freely to a distance h. The mass of the ball is m. The force that is acting in the downward direction is weight W equal to F into S. Force is mg and displacement is h. Work done is equal to mgh. So work done against the work done in the direction of the gravity is mgh. Now similarly, the same ball is thrown in the upward direction. So the displacement is in this direction h. Okay, and the weight is acting in the downward direction. So this angle is 180. Work done is equal to minus mgh. Okay, against the gravity, work done depends upon only two things. One, the weight of the body. Second, the height. I'll give you an example. Suppose you are staying in a multi-story building. You are coming down by a lift to the ground floor, or you are coming down by a stair by a staircase, or you are jumping out of the window. In all the cases, the displacement is h. Whether you are coming down by a elevator or lift, or you are coming down by a staircase, or you are jumping out of the window, in all these three cases, you are reaching from the same height to the ground floor and your own weight mg. So work done will be the same, although you may not be able to survive after you jump out of the window. Okay, so work done will remain the same. And if you are going up or you are going down to the same height, work done will be same. आप सीढ़ी चढ़ के जीना चढ़ के छत पर जाए या उतर के आए, दोनों ही केस में वर्क डन सेम रहेगा, mgh के बराबर. लेकिन चढ़ना मुश्किल होता है. हम वैष्णो देवी की यात्रा करते हैं तो चढ़ना मुश्किल होता, उतरना आसान होता है. क्यों? क्योंकि हम जब ऊपर चढ़ते हैं तो हम अगेंस्ट द ग्रेविटी काम करते हैं, तो हमें काम करना पड़ता है, हमें ताकत लगानी पड़ती है, हमें काम करना पड़ता है, इसलिए मुश्किल होता है. और जबकि हम उतर के आते हैं तो हमें काम वही काम वापस मिलता है, हम लुढ़कते हुए दौड़ते हुए नीचे चले आते हैं इन द डायरेक्शन ऑफ ग्रेविटी. लेकिन द अमाउंट ऑफ वर्क डन विल रिमेन द सेम. क्लियर? We'll now start with the next topic. The next one thing is left, that is SI unit. SI unit of work. Force Newton into meter, that is equal to Joule. So SI unit of work is Joule. Okay, 1 Joule. If 1 Newton of force displaces an object by 1 meter in its direction, 1 Joule of work is said to be done. If 1 Newton of force displaces an object by 1 meter in its own direction, then the work done is equal to 1 Joule. CGS unit, this is SI. Okay, I have written here CGS unit. We have for force, it is dyne into centimeter, and that is equal to earth. Okay, so if one dyne of force is applied on an object to displace it by 1 centimeter, then 1 earth work is done. Then we have a relationship between SI unit and CGS unit. Very important, often asked in the examination. So SI unit is joule. This is equal to 1 Newton into meter. 1 meter. 1 Newton is equal to 10 raised to power 5 dyne into 100 centimeter. This is equal to 10 raised to power 7 dyne centimeter equal to 10 raised to power 7 erg. So 1 joule is equal to 10 raised to power 7 erg. Very important formula. Okay, so you should know this derivation because it's often asked in the examination. Okay. The next topic is power. What is power? Power is rate of doing work. What is power? Power is rate of doing work. Rate means divided by time. So power is work upon time. Okay, what is power? Power is work upon time. Suppose two persons are climbing the stairs. Like two boys of different masses, they climb the stair. They reach to a same height. They do same amount of work. It's about the same amount of mass. Okay, but both the boys are of the same masses, so they do the same amount of work because they are climbing the same height. But if a person A climbs it in 2 minutes, another one in 4 minutes, then the power of the first one is twice that of second one. Okay, so power means how fast you can do that amount of work. Power of a machine means how rapidly, how fast it can do that amount of work. Okay, so we have another one. Power depends upon work. It also depends upon the time in that work is being done. Now power is work upon time. What is work? Work is force into displacement. So this is force into displacement upon time. Now we can write force into displacement upon time. Now what is displacement upon time? Velocity. So power is equal to F into V. V is velocity. Okay. So this is another formula for power. Power. One formula is work upon time. The second one is power is equal to force into velocity. Power is again a scalar quantity. The SI unit of power is joule per second. That is equal to watt. 1 joule per second is equal to 1 watt. If 1 joule of work is done in 1 second, then power is equal to 1 watt. Then we have another unit, a commonly used unit. We know that horse was considered to be the most efficient animal, very swift. So the power measured in terms of horsepower. 1 horsepower equal to 746 watt. Okay, 746 watt. Then next we have energy. You know what is energy? Energy is the ability to do work. So energy and work, for doing work you require energy, and energy is the capacity to do work. They are one of the same thing. So energy also has got the same unit. So what is the unit of energy? Unit of energy is joules. What is the unit of energy? Unit of energy is joule. SI unit is joule. Other unit of energy is, from this we can find out the energy. Work is energy. So another unit is watt. Watt hour. Watt hour is equal to 3600 joules. Okay. Then 1 kilowatt hour, another unit, that is equal to 3.6 into 10 raised to power 6 joules. The third one is 1 electron volt. This is equal to 1.6 into 10 raised to power minus 19 joules. These are certain units of energy. Watt hour, 1 watt into hour. In an hour, 3600 seconds are there. So 3600 joules. 1 kilowatt hour, 3.6 into 10 raised to power 6 joules. Then we have 1 electron volt, that is the smallest unit of energy, that is equal to 1.6 into 10 raised to the power minus 90 joules. Now, my dear students, I have completed the first part. The explanation is over. There are certain numericals that are given in your book. I hope you will try all the numericals and continue to ask any doubts if they are there. Thank you.